we'll talk about the tissue. You know that chemical level, then one level higher is the cellular. So we have already talked about chemical and cellular. So now we'll talk about the tissue. You know that many similar cells group together to form a tissue. So tissue is the collection of similar cells. 4 types of tissue form the human body. So we'll see what are those different types of tissues from the structures of the body. We'll see how we classify the tissue. 4 different types of tissues are epithelial tissue, connective tissue, nervous tissue, and muscle tissue. So we'll talk about those. So these are 4 different types of tissues: epithelial, connective, muscle, and nerve or neural tissue. First, we'll see the location of those different types of tissues in your body. Nervous tissue forms the nervous system. So very simple. What are the structures you have in the nervous system? You already know: brain, spinal cord, and nerves, right? So those are the structures formed by nervous tissue or neural tissue. Muscle tissue. There are 3 types of muscle tissues in the body: skeletal muscle tissue, cardiac muscle tissue, and smooth muscle tissue. Skeletal muscle tissue forms the skeletal muscles. And skeletal muscles, where you will find the skeletal muscles? Attached to the skeleton. So you see, very simple, attached to the bones. Also, body walls have skeletal muscle. For example, your abdominal wall here, this is the abdominal wall, right? You don't have any bone here, but skeletal muscle is here. Okay, so attached to the bones or skeleton, and in the body walls you will find the skeletal muscle. Skeletal muscle is voluntary. That means you can control. You know, if I ask you to move your body parts, you can do that, right? So voluntarily control. Cardiac muscle is a highly specialized muscle tissue, only present in the heart, and it is voluntary or involuntary? Involuntary. One will not listen to it. If it does, then it could be dangerous. Sometimes you think, oh, my life is useless. So tell your heart to stop. If it stops, then you will die. So cardiac muscle is involuntary. Even when you are sleeping, it is beating, contracting, and relaxing. Smooth muscle tissue is found in the wall of tube-like structures in the body. Number 1. So tell me, what are, can you name a couple of tube-like structures? Tube-like structures, blood vessels, right? Arteries, veins, capillaries. What else? Intestine, esophagus, right? Those are tube-like structures. Trachea. So you have smooth muscle in the wall of those tube-like structures of the body. Number 1. Number 2, in the wall of the hollow organs in the body. Those organs have cavities. So what are the hollow organs? You know, you have the stomach, right? Urinary bladder, uterus. Those are the hollow organs in the wall. You have the smooth muscle. Okay. Smooth muscle is also involuntary. So only skeletal is voluntary. So that's the muscle tissue. Now, epithelial tissue. Epithelial tissue forms the body surface covering of the body. That means the skin, epidermis of the skin, outer layer of the skin. That's the covering, outer layer of the skin. And number two, inner linings. What does mean inner linings? Outer covering we understand, the skin, right? And the outer surface of the skin is the epidermis. Inner lining is the lining inside the blood vessels, tube-like structure. So for example, this is your esophagus. This is the wall, and inner lining has the epithelial tissue. Innermost thin layer of the tube-like structures or hollow organs. This is your urinary bladder. This is the wall. So inner lining is that lines the inner surface of the cavity. So these are the inner linings, right, of the tube-like structures, innermost thin layer, or the hollow organ, innermost thin layer. So those are the places where you will find the epithelial tissue. Connective tissue is very widely distributed in your body. Most widely distributed tissue is the connective tissue. Your connective tissue forms a number of structures in the body, and they are different from each other. For example, bones are connective tissue, right? Cartilages are connective tissue. Tendons, ligaments are connective tissue. Your blood is a connective tissue. So you see that bone is very hard, blood is liquid. So connective tissue is present in many different forms and widely distributed throughout the body. Bones, cartilages, tendons, ligaments, fats are also connective tissue. Blood. Okay, so those are the locations of 4 different types of tissue. Now first we will go over the epithelial tissue. Epithelial tissue can be divided in 2 ways. One is by the location. So by location, we divide the epithelial tissue into 2 types. Number 1, covering and lining, that I have explained to you a few minutes ago. Outer covering of the body, inner lining of the tube-like or hollow organs. Okay, so covering and lining epithelium. Also, epithelial tissue is found inside the glands. So, glandular epithelium inside the glands. They secrete the chemicals. So, that is by location. Now, another way we divide the epithelial tissue, that is by looking at the shape of the cells and the number of layers. So another way is by shape and arrangement. Okay, by looking at the shape and number of layers. Let's see how we divide by looking at the shape and layer. the epithelial tissue that has the cells like this, tall cells, this nucleus inside it. So this epithelial tissue is called columnar. The cells are like tall columns. So columnar epithelial tissue. Another type of epithelial tissue that has the cells, those are cubical shape. That means height and width are almost same. These are nuclear. So this is cuboidal. Cubical shape cells. Cuboidal epithelial tissue or epithelium. In another type, you have the cells flat, thin and flat, nucleus inside. So this is called squamous. A squamous type epithelium, flat cells. The word squamous came from the scale of fish. To know the scale of fish, so it's flat, right? Thin. So came from that name. So this is another way by looking the shape of the cells, columnar, cuboidal, squamous. There is another type. That type of epithelial cells, they change their shape. They don't have any definitive shape because sometimes they are columnar, sometimes they are cuboidal, sometimes they are flat. So they have different shapes and they change their shape, and that is called transitional. That makes sense. Transitional means from one status to another. So these are the types of epithelium or epithelial tissue based on the shape. Now, if you see that the cells have formed a single layer, only one layer, for example, this is one layer of columnar, that is called simple. Simple means single layer. So this is simple columnar. This is one layer of cuboidal, so this is simple cuboidal. This is simple squamous. Okay. Make sense? So if you see one layer, that is simple. But if you see more than one layer, that is called stratified. Stratified. Now, this is simple, but if I add more layers on it, that is the stratified columnar. Stratified columnar. This is stratified cuboidal because more than one layer. No more simple. This is stratified columnar. This is stratified squamous. More than one layer. Okay. Sometimes you will see very thick, many layers. So stratified. Now another type that is called pseudo-stratified columnar. This is a stratified columnar. That makes sense. More than one layers of columnar cells. Pseudo-stratified columnar is different. If you see the epithelium that has columnar cells, these are columnar, tall, but the cells have different heights. All these are columnar, tall, but height is different. Here you see this is actually a single layer, right? This is a single layer of columnar cells. But if you see this columnar epithelium under the microscope, it gives you a false impression that it is multiple layer. Why? Because the height is different, right? So the nuclei are in different locations, right? So when you see under the microscope, you will get the impression that more than one layer is here, but actually single layer. Make sense? So that's why it is called pseudo stratified. That means false multiple layer. Pseudo means false stratified columnar. Okay, so in pseudo-stratified columnar, we often see cilia. So this is another way to make sure cilia are soft here. In the apical end or upper end, you have the cilia. So that's why it is also called pseudo-stratified ciliated columnar, because cilia are there. So this is how we classify based on the shape of the cells and the number of layers or arrangements. Characteristic, yeah.
The difference between the pseudo-stratified and the other one is the conditional, just in the shape.
Pseudo-stratified, the shapes are different, but all are columnar, right? And all is columnar and will not change the shape.
The other one is different.
Shape changes. Okay. Characteristics of epithelial tissue. Epithelial tissue is different than other tissues because it has some characteristics. All epithelial tissue cells have two ends. Just think that here I showed you different types of epithelial tissue. All epithelial tissue cells have three ends. This is the free end and this is the attached end, right? The lower end is attached on the basement membrane. So it's like this, free end and attached end. And on the free end, sometimes we see cilia, like you have seen here, or brush border, microvilli. So the difference between cilia and microvilli is just simple. Cilia are soft, okay, and microvilli are harder. Here, like both are here like a structure, but cilia are soft and can beat like this, float like this, and microvilli will stay like this. Okay, from brush border. Soft hair will move like this, and microvilli are like thick hair, will stay like this. Okay, so and they are attached on the apical surface, and the cells in epithelial tissue are, you see, every time I draw the epithelial tissue, I put the cells side by side, attached to each other. Why? Because the cells are attached to each other by the intercellular junctions or joinings. We have talked about that. So in case of epithelial tissue, the cells are attached to each other, okay, by the junctions, closely packed and held together by the junctions. Avascular epithelial tissue does not have any blood vessels. No capillaries, no blood vessels are present. Now the question is then, these are alive cells, living cells, then how they survive if they don't have the blood vessels or capillaries? They get nutrition and oxygen from the underlying connective tissue. This is the connective tissue. Always under the epithelial tissue you will find the connective tissue support. So this is the connective tissue and you have blood vessels here. So from here, by diffusion, nutrition and oxygen goes there to keep them alive. So by what? What's the process? Diffusion. By diffusion, nutrition and oxygen go there from the underlying connective tissue, because connective tissue has the capillaries. High rate of regeneration. Epithelial tissue cells can quickly be reproduced, regenerate. We all know that. You lose the skin, right? And new skin is formed. When you drink something hot, inside the mouth you have the epithelial lining, right? Lining epithelium. You burn the cells all the time. Some cells are dying when you are drinking hot coffee or tea, okay? But within, few hours, everything regenerates. And that is another very important property of the epithelial tissue. They have high rate of regeneration. In next few slides, what I'll do, I'll show you different types of epithelial tissue under the microscope, how they look like, and I'll mention few important locations. You need to underline or highlight those and remember those locations. I'll ask in the exam, okay? So not many, but few, but you have to remember. So this is a simple squamous epithelium. Why simple squamous epithelium? A single layer of what? Flat cells. Now these are alveoli of the lung. So now you see why it is saying that a single layer of flat cells. So if you see the wall of this alveoli, it's like this. This is one epithelial cell, flat. This is another. This is another nucleus. These are nucleus. This is the cell. Nucleus. Okay, another cell. So you see the wall is formed by a single layer of flat cells. Make sense? So this is simple squamous. Where you will find in the wall of the alveoli of the lung, and also endothelium of the blood vessels. That means inner lining of the blood vessels, innermost layer of the blood vessels, that is called endothelium. So I mentioned two, and one more is the inner lining of the heart, innermost layer, thin layer of heart is simple squamous. So those three, alveoli, that's the air sac, and endothelium of the blood vessels, and inner lining of the heart. Those three, remember. Simple cuboidal. Now why the picture you see here is called simple cuboidal? Because it has a single layer of flat cubical shaped cells. You see, these are the ducts, tube-like structures, and in the wall, if you look carefully, those big tube-like structures, the wall is formed by like this. Sometimes you'll see the cell membrane is lost, not seen there, but actually, if it is intact, it is like this. So cuboidal cells form a single layer. So this is simple cuboidal. Cuboidal. A single layer of cuboidal cells. Always remember, when I draw, it looks very clear, right? But when you see under the microscope, many cell members are not clearly seen. So you need practice, okay? So just try to find only one cell, then others should be same. So let's see only one that has clear boundary here. For example, this one, you see here, this one has clear boundary. So all other cells are like that. Where you will find the simple cuboidal? Kidney tubules. Inside the kidney, you have million of tubules, very tiny. So kidney tubules, and the ducts of the glands. Inside the gland, you have also tubes, microtubules. So tubules inside the kidney and ducts inside the glands. So simple columnar, a single layer of tall columnar cells. And where you will find simple columnar? In the gastrointestinal tract, inner lining of GI tract. Inner lining of GI tract. But you have to remember, not everywhere, stomach and below. That means starting from the stomach. If you go down, small intestine, large intestine, okay? So, not above the stomach. Above the stomach you have what? Esophagus here, right? That doesn't have simple columnar. So, gastrointestinal tract, but stomach and below. Inner lining is simple columnar. That is one. Let me see if you need to remember anything else. Yeah, that's fine. Then pseudostratified columnar. Pseudostratified columnar, I just explained here. See this one? You have a single layer of columnar cells, but looks like multiple layer, and this has cilia, right, on it, soft hair. That's why you see cilia in this picture. Now, just think where you should have the cells that need cilia. Respiratory tract, right? Because mucus secretion occurs all the time, right? So the mucus gets dirty because when you are inhaling water, air all the time, right? So dust particles, dirt particles are getting in and getting, attached to the mucus. So cilia are moving like this to push the mucus down, away, okay, towards the throat. So in the upper respiratory tract, you have pseudostratified ciliated. For example, nasal cavity, trachea, larynx, you have pseudostratified ciliated. Okay. Stratified squamous. Many layers you see here of flat cells. If you see the picture, you can see that the outer part of this picture, like here, the outer part, you have many layers of flat cells. Here you don't have, because these are the stem cells, different. So here this is the stratified squamous, many layers of flat cells. This is the picture of a skin. So you know that the outer layer of the skin, epidermis, has the stratified squamous. So epidermis of the skin, number one. Epidermis of the skin. Also, inner lining of those structures get friction. The chance of friction, getting friction, is high. For example, inner lining of the mouth. You know that inside the mouth, always when you chew the food, right, the friction occurs. So just remember that thing, that where the chance of friction is high, you have stratified squamous. Skin, outer surface of the skin, right, always friction. So that's why you have stratified squamous. Inner lining of the mouth, always friction when you eat the food. So stratified squamous. Number 3, esophagus. Esophagus is a narrow tube. When you swallow the food bolus passes through that narrow tube. So the chance of friction is high. That is also stratified squamous. Inner lining of vagina. Okay. So these are the places where you will find stratified squamous. Now, we divide the stratified squamous into 2 types. Dry surface stratified squamous, that is called keratinized stratified squamous in the dry surface, that means skin, epidermis of the skin. It is dry, so keratinized. And non-keratinized is in the wet surface, inside the mouth, right? Inside the esophagus, the surface is wet. So that type of stratified squamous is non-keratinized. So 2 types, keratinized and non-keratinized. Keratin is a protein that is present or not present, depending on that. Transitional epithelial tissue, the cells change their shape that I have mentioned, where you will find inside the urinary bladder, inner lining of the what? Urinary bladder. Inner lining of the ureters, those tubes transport the urine. So just in a simple way to remember, where you have the urine. You have urine inside the bladder, right? You have urine inside the ureter. So in those structures, the lining is transitional. Now why? That is the question. Why in those structures you have urine, lining is transitional? Transitional has 2 important properties. Number 1, it doesn't allow the fluid pass through it. So, when urine is stored in the bladder, if urine can pass through the epithelial lining, transitional, then it will go back to the body, right? You don't want that. You don't want the urine to get out from the bladder and go back to the body. Make sense? So that's why you have transitional there. Transitional doesn't allow the fluid or liquid pass through it. Make sense? So let's stay there. Number 2, transitional, you already know, the cells can change the shape. So by changing the shape, the cells can absorb pressure, can get stretched easily. Make sense? Like, when you put more pressure, the cells will get flat to absorb the shock or pressure. Right? And when empty, will get columnar. When more pressure, get flat. So they can absorb the pressure. So that's why those are 2 important properties of transitional. By changing the shape, they can absorb the pressure or shock. And number 2, they won't allow any fluid or liquid pass through. Stratified cuboidal and stratified columnar, these are rarely present in the body, only in very few areas. Stratified cuboidal in the mammary gland, female breast, and stratified columnar also has limited distribution in the body, small amount in the pharynx, male urethra, and lining of the ducts. So just remember the stratified cuboidal in mammary gland. That's fine for the exam. You have to read everything for exam. Okay, just remember. So I mentioned different types of epithelial tissue, showed how they look like under the microscope, right? And the important locations where you'll find. You need to remember those locations I have mentioned. Those are the important areas. Okay. Connective tissue. Connective tissue is the most widely distributed tissue in the body, and they are present in many different structures. They form many different structures are formed by connective tissue, and those structures are different from each other. I mentioned before, your bones are connective tissue, cartilages are connective tissue, fats are connective tissue, blood is a connective tissue, and tendons, ligaments, right? You see, they are different from each other, but all belong to what? All belong to the connective tissue. Is it clear? Why? Because all of them come from a single source. That's the mesenchymal tissue. That's the embryonic tissue from where all different types of connective tissue come. Make sense? They come from where? Mesenchyme. That's an embryonic tissue. So, connective tissue has the cells. Usually cells are not attached to each other. You remember in epithelial tissue, the cells are always attached to each other. In case of connective tissue, that's not the case always. So you have the cells like this in most of the cases, and in between the cells you have matrix. But in epithelial, you see there is no space in between the cells. Okay? So no matrix. But here in connective tissue, in between the cells, you have the matrix. So cell and the matrix in between the cells. Now matrix has two things. Matrix could have fibers and ground substances, other chemicals. So inside the matrix you will see fibers and the other chemicals, that is called ground substance. Okay. So that's the connective tissue. Go ahead. Again? Okay, so connective tissue has cells, different types of cells, and in between the cells you have what? Matrix. So matrix is here, right? In between the cell. In the matrix you have what? Fibers. Not always, but in many cases you will see the fibers, and rest part is the ground substance. Make sense? So matrix consists of the fibers and the chemicals called the ground substance. So
What's the function of the matrix?
function of the matrix. Yeah, matrix have different types of connective tissue, have different types of matrix. For example, blood. Blood is a connective tissue, right? So in general, we cannot say. So blood, as the blood cells, you know that, red blood cells, white blood cells, and matrix is called the plasma. Plasma has many different functions. We'll talk about that in NP2. In case of bone, you have the matrix, that is calcium. Calcium forms the matrix of the bone, so it has different functions. Make sense? So different matrix has different functions. Functions of the connective tissue. Number one is connecting the parts together. For example, cartilages, tendons, ligaments. You know that those structures are to do what? Connect, right? Ligaments connect one bone to another. Tendons connect muscle to bone. That's the difference between tendon and ligament, okay? Tendon connects muscle to the bone, with the bone. And ligaments connect bone to bone, right? Cartilages connect the bones, you see here. These cartilages are connecting the ribs to the sternum, right? So, connection is number one. Protection. Bones belong to connective tissue, and you know already, I have explained in last class that bones protect your important organs. For example, the cranial bones protect the brain, the facial bones protect the eyeball or tongue or nasal cavity. You know, your heart is protected by these ribs. So the connective tissue protects important organ. Support. You know, the skeleton is formed by connective tissue, right? Because here you have the bones and cartilages. So we know that skeleton supports the whole body. Make sense? So which is formed by what? Connective tissue, bones and cartilages. Flexibility. One type of cartilage that is called elastic cartilage that is present in the structures, those have flexibility. For example, your ear, right? Epiglottis moving up and down. When you swallow the food or not, the epiglottis moves. Ear can change the shape. So that's the flexibility, elastic cartilage. Transport. Blood is a connective tissue, and you all know that blood transports important chemicals, right? From one place to another. So those are few important functions of the connective tissue. Now, you know that connective tissue has the cells and also has fibers in the matrix. So, three types of fibers are present in the connective tissue. Three types of fibers. What are those three types of fibers? Collagen fibers, elastic fibers, and reticular fibers. Among these three, collagen fibers are most common, most abundant in the connective tissue. Elastic fibers are present in those structures that have elasticity. Reticular fibers. Reticular fibers are present in mainly in the lymph organs. For example, lymph node, spleen, liver, those organs have plenty of reticular fibers and they form network. So spleen, tonsil, lymph node, liver, those organs have reticular fibers. So these are three types of fibers. Cells, many different types of cells, because we know that bone is a connective tissue, so bone cells are connective tissue cells. Make sense? Cartilage is a connective tissue, so cartilaginous cells are connective tissue cells. Blood is a connective tissue, so blood cells are connective tissue cells. Fat is a connective tissue, so fat cells are also connective tissue cells. Make sense? So that's why the many different types of cells are present in the connective tissue, depending on which structure you are talking about, right? Because there are so many. So bone cells are called osteocytes, right? Osteoblasts, osteoclasts. Chondro means cartilage. So chondrocytes, chondroblasts are connected, cartilaginous cells. Chondro means cartilage. Osteo means what? Bone. So osteocyte, bone cells. Chondrocytes, cartilage cells, right? Just remember one thing, which is very important. All those are connective tissue cells, but the connective tissue cell, which is the most common, that is the fibroblasts. Fibroblasts produce the fibers. Fibroblasts. You will find in many types of connective tissue. Commonly. Now, I'll show you the classification of connective tissue. How we classify the connective tissue. You will need a lot of space in your paper. So, get ready. Okay. Let's see. So, this classification is very important. If you just remember this, it will be easy for you to follow everything. So, connective tissue. First, we divide the connective tissue into connective tissue proper, tissue proper. That's the main type. And then others belong bones, cartilages, blood, or we can say liquid type connective tissue. So this is how first we divide the connective tissue into connective tissue proper, bones, cartilages, and liquid. Connective tissue proper is two types. Loose connective tissue proper and dense connective tissue proper. In loose, you have few or no fibers. So in loose type, you have only few or no fibers. That's why the structure is soft, loose. In dense, you have plenty of fibers. Lot of fibers. Plenty of fibers. That's why it is dense, densely packed and hard. Okay, more fibers means it is harder. So that's why one is loose, another is dense. Now loose could be three types. Loose areolar, loose reticular, and loose adipose. So these are three types of loose connective tissue proper: areolar, reticular, and adipose. Adipose is fat. Dense could be two types: dense regular and dense irregular. Both have lot of fibers, heavily packed. Okay. Now, bones. Bones are two types. One is called compact, that is the hard bone, and spongy, that's the soft bone. Okay, so compact is the hard bone, spongy is the soft bone. Cartilages. Three types of cartilages. The most common is called hyaline cartilage. Then you have another type that is called elastic in the ear and epiglottis. Elastic. And third one, fibrocartilage. Lot of fibers. Fibrocartilage. So those are three types of cartilages. And liquid connective tissue includes blood. Blood is a connective tissue. Also lymph fluid inside the lymphatic system. So these are in liquid form. So that is the classification of the connective tissue. Okay. Make sense? Uh, uh, if you just follow this, then it will be easy for you to do the lab as well as the lecture part. Okay. So now what I'll do, I'll just go over these different types of connective tissue, how they look like, and just couple of structures where you'll find them, like the epithelial tissue. I'll mention only few. You have to remember those. First, let's go over the connective tissue proper. Loose type. First, loose areolar. This is the loose areolar type connective tissue proper. Loose areolar is easy to identify because it has two types of fibers. By looking at those, you can tell this is loose areolar. You have collagen fibers, those red fibers. You see the red color? Sometimes they form bundle. So red colored fibers are collagen fibers, and also if you look carefully, thin dark hair-like fibers, those are the elastic fibers. You remember I mentioned in connective tissue we have three types of fibers, right? Collagen, elastic, reticular. So in this one you have two of those. Which two? You have collagen and elastic. So if you see, that's the loose areolar. Where you will find it? Under the epithelial tissue. You remember every time I did draw the epithelial, I draw something, then I draw the epithelial tissue, right? So this is the connective tissue I mentioned. Remember that? So that is called the lamina propria, also called basement membrane. So lamina propria under the epithelial tissue. So it supports the epithelial tissue. Okay. And your epithelial tissue gets nutrition and oxygen from here. You remember I mentioned that. So that's the loose areolar type connective tissue. That is one location. Another is around the blood vessels of the body. So it provides cushion around the blood vessels. Just think that if around your blood vessel you have hard tissue, then what will happen? If I press or if you get, crushed by something, the blood vessels will be destroyed, right? Because of loose areolar tissue around the blood vessel, if I press, right, blood vessel will get some space to move. Is it clear? It will get some space to move away. So that is the support. So just remember those two locations, lamina propria under the epithelial tissue and around the blood vessels. You have the areola. Adipose. So this one is fat. Adipose is fat. The fats or adipose connective tissue, it's very easy to identify. It has white round cells, and these cells are mostly empty. Only some fat globules are present inside, but mostly empty. And nucleus, that is another thing. Nucleus is not in the center but attached to the cell membrane, like this. So nucleus is attached to the cell membrane. So this is the adipose or fat. Very easy to identify. So no fiber. That's why I said that loose, few or no fiber. You know where fat is found in the body. Uh, Under the skin, subcutaneous fat in the breast, plenty of fat there, other locations. Uh, Another type of loose is reticular. This is very easy. Reticular one has reticular fibers. That's why it is called reticular. Okay? Why it is called reticular? Because it has reticular type fibers. What are three types of fibers in connective tissue? Collagen, elastic, reticular, right? You have seen, let's go back. We have seen collagen and elastic here, right? The red ones are collagen and thin dark elastic. Make sense? So you got two here, and this one doesn't have any, and this one has reticular fibers. Make sense? So you got all three. Reticular fibers form network, and I already mentioned that this type of connective tissue is present in the lymph organs, tonsils, right? Lymph nodes, spleen. So those organs have the reticular type of connective tissue. Okay, so we are done with loose. Now let's see the dense. Dense is two types, regular, irregular. The fibers are heavily packed. That's why it is called dense. It is hard. Now, dense could be two types. Why we say regular? If you see the collagen fibers, both are filled with collagen fibers. If you see the collagen fibers all are going in same direction, that is called regular. Makes sense. All fibers are going in same direction, same way. So that's the regular. If you see some fibers are in one direction, other fibers are forming bundle and they are going in different directions. So that is the irregular. Okay. So dense, regular and irregular. Both are heavily filled with collagen fibers. And now, where you will find the dense regular, just remember a couple of structures. Tendons and ligaments. Those are very hard and strong, you know that, right? Tendons are very strong and hard because you have a lot of fibers in it. Dense irregular, you see, this is dense irregular, and where you will find it, dermis of the skin. That means under the epidermis. Epidermis is epithelial tissue, you know that. So under this epidermis, you have the dermis. Dermis is formed by dense irregular, number one. Number two, joint capsules. Around the joint, you have the membrane that is called the capsule of the joint. So in joint capsules are formed by dense irregular. Okay. So just remember those two, dermis and capsules of the joint. So that's the proper. We are done with proper. So now let's talk about the cartilages. Three types, hyaline, elastic, fibro. Hyaline is the most common. Hyaline is the what? Most common. I'll mention the structures where you will find the hyaline cartilage. So let's see first the picture. So this is hyaline cartilage under the microscope. This one is easy to identify. Why? Just write it down. Few cells, plenty of matrix. Number of cell is few, but since the cells are few, it has a lot of what? Matrix in between the cells. No visible fiber. No fiber is visible here. Where you will find it, hyaline cartilage forms a number of structures. Number one, skeleton of the fetus. So fetal skeleton. In very early stage of life, whole skeleton is hyaline cartilage. There is no bone. So skeleton of the fetus. Then the hyaline cartilage is converted to bone later. You get it? You know fetus? Skeleton, whole skeleton of the fetus. It's a small baby before birth. Okay. Number two, costal cartilages here in the attached to the ribs. These are hyaline cartilages. These are called costal cartilages attached to the ribs. Then in the respiratory tract, your trachea, larynx, right? Respiratory tract, trachea, larynx. Those structures are formed by hyaline cartilage. Number four, cartilages in the joints. Those are called articular cartilages. You already know the joints have cartilage, right? So covering the bone, end of the bones. Like here, this is a joint. These two bones are covered by hyaline cartilage, articular cartilage. So just remember, those are the structures where you will find the hyaline cartilage. Those structures are formed by hyaline cartilage. Make sense? Can you mention a couple of those?
Would you say that the upper respiratory tract is the tissues that are in the lower respiratory tract?
When we talked before? No, now. Now enter respiratory tract in the bronchi, in the trachea. Not only upper respiratory, trachea, larynx, right? Then also in the bronchi, you have the hyaline cartilage. So just respiratory tract. That's why I said respiratory tract. I did not mention upper. Okay? Upper respiratory I mentioned when we talked about pseudostratified ciliated column. Now that's the upper respiratory tract. So mention few structures where you will find the hyaline cartilage. Number one is what? Fetal skeleton. Very good. Number two, costal cartilages. Number three, respiratory tract, right? And number four, articular cartilages in the joints. Okay. Articular means joint. So and again, few cells and plenty of what? Matrix. No visible fiber. Now elastic. You see the picture. Elastic is opposite. Many cells, small amount of matrix. So just opposite. Many cells, small amount of matrix, and fibers are present. So just opposite of hyaline. What kind of fibers? Elastic fibers. You know only three types of fibers I have mentioned, right? Collagen, elastic, reticular. And this is elastic type cartilage. So what kind of fiber it should have? Elastic fibers. Make sense? So you see those thin dark lines, those are the fibers in the matrix. Okay. Where you will find only in few structures. Your ear, it has elasticity, right? Ear. and epiglottis, I mentioned already before. Both start with E. Remember those two. Fibrocartilage. Very easy. Its name is telling you. Fibrocartilage should have lot of what? Fibers. You see here, lot of fibers. That's why it is fibrocartilage. Where you will find fibrocartilage, very important. Few structures. Number one, intervertebral discs. You know, these are the intervertebral discs in between the vertebrae. Fibrocartilage. Okay. Pubic symphysis. This piece of cartilage here that connects the hip bones here. This is called pubic symphysis or symphysis pubis, same thing. So this cartilage is fibro. This is fibro. And another is meniscus of the joint, knee joint. You know meniscus? Probably you have heard, all of you, right? Sometimes torning of meniscus. So meniscuses of the knee joint. Those are the structures where you will find fibrocartilage. So I am going back. What is this? What type of cartilage? Hyaline. Few cells, lot of matrix. This is elastic, right? Opposite, that means what? Sorry, opposite, that means what? Many cells, small amount of matrix, right? And fibers. And this is fibro, that means plenty of fibers. Make sense? So those are three types of cartilages. Not difficult if you just keep those things in mind. Now we'll see the bone. This is the compact bone under the microscope. So how it looks like under the microscope. Bone consists of osteons. Very simple, you see here. If you see the structure of the bone, compact bone, it is like this. This is the compact bone. It is formed by many columns. Many columns are bundled together to form the compact bone. Make sense? So each column is called an osteon. So that is the structural unit of the bone. So this is one osteon, this is another osteon. So many osteons are bundled together to form the compact bone. Make sense? Now, if I make a cross section of bone, cut like this, make slice, okay, this way, and see under the microscope, what I will see? I will see like this, right? Round circles. So that's what you are seeing here. You will see round structures or osteons. So this is one osteon, one column. This is another, this is another, this is another. Now if you focus on one osteon, in the center of the osteon you have a canal that is called the central canal. Okay, central canal. Habershell canal, yes, also called Habershell canal, and it contains blood vessels and nerves. So blood vessels and nerves are passed through the central canal. So all osteons have central canal. Then you have what? You have osteocytes, because osteocytes are the bone cells. So these are the osteocytes, and osteocytes have tiny leg-like structures. So they look like spiders, like this. Okay. So these are the what? Osteocytes. Osteo means bone, cyte means cell. So osteocyte. Osteocytes sit inside tiny cavities. So this is the cavity in which the osteocytes are located. These cavities are called lacunae. M-A-E, or you can also say M-A. So lacunae are the tiny cavities. Inside that you have the osteocytes. So lacunae are tiny cavities that house the osteocytes. So you have many lacunae like this and the osteocytes inside. Osteocytes inside. So we can say osteocytes within lacunae. Okay. Now you know that in connective tissue, in between the cells, you have what? Matrix. So this is the matrix of the bone in between the cells, in between lacunae. And that matrix of the bone is soft or hard? What do you think? Very hard. Because bones are very strong, right? Hard. Bones are very hard. So matrix of the bone is very hard. This matrix, hard matrix of the bone, has a name. It is called lamella. So lamella is the hard matrix of the bone. Okay. So that's the structure of the bone. Okay. The difference between compact and spongy is that in compact bone you'll see the osteons are very nicely organized. In spongy, many broken osteons we see. So that's the difference. In spongy bone, we see many broken osteons, incomplete osteons, but in compact, you have all osteons are very nicely present. That's the difference. The last one, the liquid form of connective tissue is the blood, and if you see the blood, you will see different types of cells and plasma. Plasma is the matrix in this case, so which is liquid. So in blood, the matrix is the plasma, which is liquid, and red blood cells, white blood cells, platelets. Here you see most of the cells are red blood cells. Only 2 white blood cells are present here. You see that they have nucleus inside, and I see here only 1 platelet. That's very small. Platelets are very small. This one. So red blood cells, white blood cells, and platelets. And in between you have the plasma, the liquid portion of the blood. Okay. Okay. So that's the connective tissue. So we are done with 2 main types of tissues, epithelial and connective. Nervous tissue is very important because it forms the nervous system, but simple. Yeah. Yes, the compact, in compact you will see the osteons, all osteons are intact and nicely bundled. Okay. In case of spongy, you will see many broken, incomplete osteons. So under the microscope, it doesn't look pretty. Okay. You will see incomplete osteons. Nervous tissue. Nervous tissue forms the nervous system. That means found in the brain, spinal cord and nerves that I mentioned before. Nervous tissue is highly sensitive and very delicate. You know that, right? the brain or spinal cord, highly sensitive and delicate. Two types of cells are present in the nervous tissue. Main cells are called the neurons and supporting cells are called the neuroglia. So glial cells are supporting and neurons are the main. Make sense? Okay. Second, neurons are the main cells, main type. And glial cells, neuroglial cells are what? Supporting cells. Okay. Now, in a neuron, you'll see a number of processes that I showed you at the very beginning today, different types of body cells. You remember the neuron has a cell body, nucleus and processes. Okay, axons and dendrites. So if you see a neuron, this is a neuron. It has a cell body, nucleus and processes are like this. This is an axon and these are called dendrites. And this is the cell body. So these processes do what? Transmits electrical signal. That's why neuron has processes. Transmit what kind of signal? Electrical signal. You know, nerve signal transmission is electrical signal transmission. So neurons transmit electrical signal. The neural tissue forms the nervous system, and you already know that nervous system is called first acting control system. Remember, it is very powerful control system. So it controls the body functions. This is how the neural tissue is under the microscope. So you see the large cells, those are the neurons, and you see many tiny dots, those are the neuroglial cells, supporting cells. So neurons are much bigger, larger, have processes. You see the processes, let's say this one. This is the cell body, and then you see the dendrites and the axons, right, attached to it. So the neuron has processes, but neuroglial cells are these dots, many dots you see there, those are neuroglial cells. They have important functions too. When we'll talk about the nervous system, we'll talk about the functions of neuroglial cells. Yes. Where? You see many tiny dots. All this is one, these tiny dots are neuroglial cells everywhere. And these are the neurons, the big ones. Muscle tissue. Three types of muscle tissues. You know the locations, I have talked about that already. Now, skeletal muscle tissue. If you look under the microscope, the fibers are cylindrical, like cylinders in your chemistry lab. Have you seen cylinder? This, right? So cylindrical fibers. Number one, cylindrical fibers, long cylindrical fibers. Number two, inside the fibers you'll see striations, clear striations, lines like this. Striations. In each fiber you have many nuclei like this, multiple nuclei, but nuclei are not in the center of the fiber attached to the membrane. So we say peripherally located multiple nuclei. Make sense? Not located in the center, located peripherally, away from the center. How many? Multiple. So those are the histological properties. That means under the microscope, if you see the tissue, you will see those are the things, and by looking at those things, you can tell this is a skeletal muscle tissue. Make sense? And skeletal is voluntary. You know that. Cardiac muscle. Cardiac muscle fibers are also cylindrical. So cardiac muscle fibers are also cylindrical shaped fibers like this. Now they also have striations, but striations are kind of fade. You will be able to see under microscope, but not as clear as skeletal. So cylindrical fibers, striations are present. Those two things are common, skeletal and cardiac. Cylindrical and striations. So they are also present in skeleton. Now, what are the things different? The nucleus is usually only one. Usually, we see a single nucleus. Occasionally, could be two, but not more than that. So, usually single nucleus. Single nucleus, okay? Another very important thing that is called the intercalated disc. There is a thick band is present in between the fibers. So this is one fiber and this is another fiber. So in between two fibers are attached by a thick band that is called intercalated disc. Only present in cardiac muscle. They have here another fiber here, so intercalated disc. Okay, and you see branching is also present in cardiac muscle. That means from one fiber, the branch gets out and go to the other fiber. So this is called branching. Present. So these are the histological properties of cardiac muscle tissue under the microscope. Cardiac muscle is involuntary, doesn't listen to your command. Now the last one, smooth muscle. Smooth muscle is very simple. The fibers are not cylindrical, spindle shaped fibers. You know what is a spindle, right? Spindle shaped like your eye. Both ends are narrow, pointed, middle part is wide, right? So that's the spindle shaped fibers. So that's how the smooth muscle, no striation, no intercalated disc, no branching. Okay, so very simple. Only a single nucleus nicely located in the center. So spindle shaped fibers, single nucleus located centrally. Single centrally located nucleus. No striation, no intercalated disc, okay? No other things are present. This is also involuntary, and I mentioned at the beginning today, in the wall of tube-like structures, in the wall of hollow organs, you have the smooth muscle, right? So you know the locations. So those are three types of muscle tissue. Okay, okay, so you have learned all four different types of tissues, their classifications, properties, how they look like under the microscope, right? Those are the things you have learned in this part, right? Lot of things. Yeah. So, uh, inflammation. Inflammation is the response of the tissue to injury. Response of the tissue to what? Injury. How your tissue responds? You all know how your tissue responds, right? If something bites you or scratches you, how your tissue responds? Color gets what? Red, right? Redness. Swelling, right? Redness, swelling, pain. If you touch that area, if a lot of inflammation, it is warm or cold? Warm, right? So heat. So those are pain. So those are the signs of inflammation. Signs of inflammation. That's how the tissue responds, by showing those changes. By showing those changes. Make sense? Now, why those changes occur at the site of inflammation? You know, when you get injury, for example, these are the cells in your tissue, and you know that in the tissue you always have the capillaries. These are the capillaries, okay, in the tissue, and you also have nerve endings in the tissue. So these are the nerves. You have all those things in the tissue. Now, when injury occurs, some chemicals are released there, okay, from the cells. The main chemicals are released here are histamine, and another is called prostaglandin or PG. Okay, so those are the chemicals released here. Another is called bradykinin. Anyway, so just know that few chemicals are released there, and these chemicals do what? Mainly histamine dilates the capillaries. So more blood flows in that area. So when all these capillaries get, blood vessels get dilated, more blood will go there, right? Make sense? So that area will look what? If more blood circulates, red, right? So that gives the redness. Okay? Now when the blood vessels or capillaries dilate, you know that in the wall of the capillary you have pores, tiny holes, right? So when the capillary wall gets dilated, what happens? The pores get bigger. So water leaks, fluid comes out. Make sense? And will do what? Fluid will accumulate. More fluid will accumulate in the interstitial space, in that area. Fluid, right? So that will cause what? Swelling. So redness is due to more blood flow, right? Swelling is due to the leakage of the fluid that comes out, and pain is mainly given by this one, prostaglandin, irritates the nerve endings. The nerve endings get irritated by or stimulated by prostaglandin, that causes the pain. Okay, so those are the signs of inflammation and why that happens. The last thing, tissue repair or healing of the tissue. After injury, we know that the repairing of the tissue takes place. Now, few things happen. Few things happen during the tissue repair or healing. First, what happens is, see, in that area where the tissue has been destroyed, fibroblasts produce fibers. You remember at the very beginning I said fibroblasts produce what? Fibers. Fibroblast, the name is telling you. Connective tissue cells, right, produce fibers, collagen fibers. So the fibroblast will produce collagen fibers and that will fill the gap. Okay, bridge the gap. That's number one. Then macrophages, you already know, we have talked about all those cells. You remember different types of cells. Macrophages have processes and they love to do what? Engulf, right? So macrophages will engulf the dead cells, okay, debris, and clean that area. So filling is done by what? Which type of cells? Fibroblasts. Cleaning is done by which type of cells? Macrophages. So filling, cleaning. Then branching. Next is branching. From adjacent blood vessels, new branches are formed and those branches, blood vessels, enter into that area. So branching from adjacent blood vessels. And the last of all, covering. The surface will be covered by the epithelial tissue, you know. And you know epithelial tissue regenerates very quickly, right? So we'll cover the whole area. So filling, cleaning, branching, covering. Make sense? Filling by fibroblasts, cleaning by macrophages, branching by the adjacent blood vessels, and covering by the epithelial tissue. Regeneration. So that's how the healing or repair. Okay, so that's all.